Hello everyone, I'm Paul and today we're solving problem 2900, longest unequal adjacent groups, subsequence 1. This is an easy problem and here we will go through the intuition, approach and efficient solution, so keep watching. This is a long description, but basically we are given a string array words and a binary array groups, and we need to return an array with the longest subsequence of words in which every word corresponds to alternating values in groups. Let's see what this means with an example. Let's say this is words and this is groups. First, a subsequence is a group of elements in the array that we can build by removing some or any of the elements in the group and maintaining the order. For example, E and B is a subsequence. A and B is also a subsequence. B, for example, is also a subsequence. Now, here we could take E and B, for example, and this corresponds to 0 and 1, and given that 0 is different from 1, we have an alternating subsequence in groups. And this means the subsequence E and B is valid. And also this happens to be the longest subsequence or the longest valid subsequence for this example. And we could also take A and B, and this would correspond to 0 and 1. And these are also alternating elements, so this means A and B is also valid. So basically we have two valid subsequences here, A and B, E and B. Both of them are of length 2. This means both are the longest, so both are valid. So we return an array with A and B, for example. Now, in case you didn't notice, we don't care that much about this array. Our attention is here in groups, because if we find alternating elements here, then we can just add the corresponding elements here to the result, and that's it. So we will focus here. We will iterate this from left to right, and we will keep track of two variables. Last, which is initially the first element in the array, which is 0, and the result will be initially an array with the first word in words. So this will have an E. Because, for example, let's imagine these elements didn't exist, so we only have a 0 here, so we return our only word in the array. Now, going back to the example, remember we are focusing here and we are iterating this from left to right, and we will start from here. So the I pointer is here at index 1 and the value is 0, and we are checking if this value is different than our last value, and if it is, we are adding the corresponding letter to the result. If it isn't, we continue. So in this case, 0 equals 0, so we continue. Next, the I pointer is here at index 2 and we have a 1, and the last value of groups was 0, and 1 is different from 0, so now the last one is 1, and given that we found a different value from the last one, we add the corresponding word, in this case a B, to the result. So the result is now EB. Finally, we update I, we reach the end, and we return this. This is the entire approach. Time and space complexity for this one will be big O of n. And now we'll go with the code and hopefully you will get the idea. First, n equals length of groups, last equals groups 0, current equals an array with words 0, and for I in range from 1 up to n, if groups at I is different from last, well, in this case we update last with groups I, and we add to current words at I. Finally, we return current. This is the entire approach, and now we'll submit this and see if it works. And as you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.